G'day team, welcome back to another video, and today we are going to continue looking at normal distribution, but more specifically we're going to look at the standard normal distribution, and we're going to represent this with a Z. Now Z is a really special normal distribution because it is a normal distribution with a mean of 0 and a standard deviation of 1. And what it does, it allows us to sort of transfer between X variables and this Z variable when we don't specifically know the standard deviation or the mean of the X variable. And it's super duper handy to use. Now, if I have X that's normally distributed with a mu as a mean and a sigma as my standard deviation, then X goes to Z in the capital sense, so that's my variable, such that little z is equal to X little x take mu over sigma. Now this is the Z score. So instead of the X score that we would put in our X variable, we're now going to transfer it to a Z score, okay? So this is our normal distribution. So this is my actual score X. These are my basics, mu, standard deviation. We saw this in the last video. Now these correspond to very easy Z scores. So the mean will have a Z score of 0, then one standard deviation above will be 1, then 2, then 3, but then also -1, -2, -3. And it really simplifies what we can do when we're not given the mean or the standard deviation. So if Z equals 2.3, then X itself is 2.3 standard deviations above the mean. We might not know exactly what that value is, but we know how far above the mean it is. If it's negative 0.2, then X is 0.2 standard deviations below the mean. Again, we won't know exactly what that X value is per se, but we know whereabouts it sits in our normal distribution. So just a few little things. This is what we were looking at in the last video. So the probability that X is greater than or equal to X1, that is going to be the same as the probability of Z being greater than or equal to Z1, where X1 and Z1 are corresponsive. So Z1 is the Z score for an X1 original score. So coming down, less than still works, and then our in between X1 and X2 still works for our Z score and our Z distribution. So let's have a look at an example. So Mr. Virgo typically plays golf at Blue Lake and Adamara. Blue Lake has a mean score of 91 and a standard deviation of 5. Adamara has a mean score of 93 and a standard deviation of 4. So if I hit an 88 at Blue Lake and a 91 at Adamara, find the Z scores for both and determine which round was better. So we saw Z scores have a little formula. So this is my Blue Lake version. So my Z score is going to be X take mu all over sigma. So so my score at Blue Lake was 88. Now the mean is 91. So I subtract 91 and I divide by the standard deviation of Blue Lake, which was 5. So we're going to put that into our calculator. I've got -3 divided by 5, which is -0.6. If I'm looking at Adamara, we're going to use the same process. We're going to use the same formula, X take mu over sigma. However, my score at Adamara was 91. The mean at Adamara is 93. And the standard deviation is 4. So I've got -2 over 4, which is -0.5. Now, typically you would say -0.5 is a higher score as it's more positive, but you got to look at the context of the question. In terms of golf, a lower score is better. So that means Mr. Virgo had a better round at Blue Lake because it's a lower standard deviation below the mean. Okay. Using the calculator, determine the probability of Mr. Virgo scoring a score at least one standard deviation below the mean at each course. Now, the beauty of this one standard deviation is we can use our Z scores and we can do the calculation for both. The probability is still the same, no matter what the mean and the standard deviation are. And we know that because that probability is the probability of Z being less than or equal to 1, -1, because it's below the mean. So we've got a lower, an upper, a standard deviation, and our mean. So my lower value in this case is going to be times 10, negative times 10, 99. My upper is going to be -1. My standard deviation is 1, and my mean is 0. We're going to use the distribution for a z-score. So if I have a look at this, -1, 1, and 0, I get out the probability of being one standard deviation below is 0.159 approximately. Okay, that will be the same value for both courses. Now, if you also did it the way of using the actual scores, one standard deviation below the mean for either of them, let's use Blue Lake for example, 91 take 5 is 86. So we want the probability that x is less than or equal to 86. So that means my lower, upper, standard deviation, and mean, and this is all for Blue Lake now. So my lower is still negative times 10, 99. My upper is 86. My standard deviation was 5, and my mean was 91. If you put that into your normal distribution calculator, you'll get 0.159, which is the exact same value as over here. So you can sort of see how -1 being one standard deviation below the mean corresponds to 86, which is one standard deviation below the mean. Hopefully that gives you a bit of an idea of how to attack the questions in the textbook. Thank you very much for watching, and I'll see you in the next video.